Okay, I'm going to try to finish off section 2.1 right away because I ramble, and I endlessly ramble. But there's something I forgot to explain, and this is my old age coming in. It helps to remember what the factors of something where it's something with the same exponent minus something with the exponent, same exponent. It's always going to be x minus y, and then it's going to be this. So here it is here. See if you can see a pattern. Okay, first of all the symbols in between are now plus, but also the first one is just x to the 6, and then plus x to the 5, y to the 1. What do those add up to? If you just want to keep track, it's 6. And then x to the 4, y to the 2, those again add up to 6. And you'll notice you'll be able to keep track from this first one, which is one less than what you started with. And then x to the 3, y to the 3, plus x to the 2 times y to the 4, plus x to the 1, y to the 5, and plus y to the 6. And you'll notice that each of the x exponents go down until it becomes 1 and then nothing. And each of the y exponents start with 0, because that's 1, and then goes 1, 2, 3, 4, 5, 6. So all the x exponents go down while all the y exponents go up, and they both always will add up to the starting one. And the starting one will always be 1 less than what you started with. So you're always going to have x minus this as a factor, and then you're always going to have this left over. So I need you to sort of either learn how to look that up or learn how to remember that. The same is true for x plus y, x to the 7 plus y to the 7. I'm just using to the 7 as an example. It could be 8, it could be anything. And the factors of this will always be this. And I'll just get rid of it. And it'll always start with x plus, which is what it's in there, and then all the other ones are going to be minus. Is it minus or is it plus? Is it alternating? Hang on. Oh, it's alternating. Okay, and let's see if the other one's alternating. I don't think the other one was alternating. No, they're all plus. So they're alternating. So it's going to go plus. So it's going to go minus is the first one, plus is the next one, minus is the next one, plus is the next one, minus is the next one, plus is the next one. Okay? So it's going to start off with plus here and start off with minus there. And notice the x starts to the 6, then to the 5, and the y's to the 1, then to the 4, and the y's to the 2. And also notice, be aware that they're multiplying each other. Okay? And that's how you remember it. Okay? Also keep in mind, that's the best thing to keep in mind, is because I sort of didn't explain that clearly. It's very different from this to the exponent of 7, which I was doing for Pascal's pyramid. That's when you'll need a Pascal's pyramid, when you're expanding a binomial or trinomial. A binomial multiple times itself. And that's when you'll need Pascal's theorem, which is very useful. Oh, sorry, this is 4, 3, 1. 1, 4. Did I get it right? 3. Yeah, it's going to be 1, 4, 7, 7, 4. I probably got that wrong. But anyway, Pascal's theorem, Pascal's pyramid is easily looked up, and it's well worth memorizing. It's where you're adding up the middle numbers each time. So you get 3, 3. There we go. Now I got it. 1, 1. And then it's going to be 1, 4, 6, 4, 1. And it's going to be 1, 5, 10, 10, 5, 1. And it's going to just keep going on. You keep adding up these numbers, and you always have a 1 on the outside. And it kind of follows the same rule in that the first x is going to be x to the 7, and then whatever the symbol is. The next one's going to be x to the 6, y to the 1. And the next one's going to be x to the 5, y to the 2. And they're always going to add up to 7. So it helps to know that so you don't have to go to a calculator, especially during a test. But when you're working at home and just practicing, you can always do Symbolab, but just make sure you know how to do it. All right, moving on. This one. I'm going to take number 10. And number 10 is using a very specific distance based on time. And it's saying that we have a formula here for an object that's moving, and it's saying that this distance is based on negative time squared, so it's a downward facing parabola. And you'll have to know that when you're taking a derivative of a distance equals time formula, you end up with distance over time, which is velocity. So whenever you take a derivative of an expression, a function where distance is equal to something based on time passed, the derivative is always going to be the velocity. And you're going to learn later on that the derivative of the velocity one, again, the second derivative, is something called acceleration, but we'll get to that later. First of all, before you ever answer a question, know what you're dealing with. So what are we dealing with here? A downward facing parabola. But it helps if you factor out minus t here, and you end up with t minus 8 as this. And this immediately tells you quite a bit of useful information. That was a terrible line. And that's one, that this parabola goes through 0, 0, and 8, 0. How do I know that? Because when t is 8 here, this whole thing becomes 0, and thus the y becomes 0. Which means, since it's downward facing, the vertex is going to be halfway between those x values, which is 4. And if I plug in 4 into the original equation, I get minus 16 plus 32, which is plus 16. So that just helps to know what you're dealing with. Also know that when we're dealing with time, we only care about what happens in forward time. We don't care what happens in negative time. Negative time doesn't exist in the real world. We also tend to only deal with distances above, away from the origin, but that might change. Okay, now we can move on to the question. Find the velocity when t is equal to 0, t is equal to 4, and t is equal to 6. So they want you to use the same formula, which is f of x. Well, in this case, it's f of t, and it's not f, it's s. So they want you to find s of t plus h minus s of t all over h. And they want you to start with 0. So when we plug in 0 here, we know we're going to end up with 0. So for the first one, we're not subtracting anything. We just have to find what t plus h is. And what are we dealing with again? 0 plus h. So you're giving the time, when they give you a specific time, you're putting the actual time into it. And then you're solving for it. Well, we know that 0 plus h is the same as h. So all we have to do is solve for h over here. And we end up with, and we're going to discover that there is no, well, we'll see what we discover, okay? So when I put h into this formula, I get minus h squared plus 8h. And when I take a minus h out, I'm left with h minus 8. And actually, I probably should not have taken, let's just take the plus h out. So when I take a plus h out, I'm left with minus h plus 8. So that's supposed to be an h over here. And we can see that they cancel out. And now I can figure out, as h approaches 0, this thing becomes 0, and I'm left with plus 8. Which means that when t is 0, the acceleration of this graph is 8 meters. I believe they gave it in meters. Yeah, meters per second. So it's going up. If we were to draw the tangent line, it would look like that. Makes sense. It's quite steep. And then, by the way, it then later on asks us for 6, which is going to be right about there. If they were asking us for 8, we'd have the same exact answer, but negative 8. That's because this side of the parabola matches this side in terms of slope, but they don't. Okay, let's go to the next one. You can see how easy it is once you have the formula, and you can use either formula for substitution. I'm just going to tend to use the original. So now we're going to solve for 4, and I don't have to, because I know 4 is the peak of this vertex, because I analyzed it, and at the peak of a vertex, the slope is 0. Now you can do the math of it if you want, and the math of it is this. You're going to do s of 4 plus h minus s of 4. And I know from what I just did, when I plug in 4 in, I get 16. So s of 4 is minus 16. And then when I plug this in, I just plug it into this. Now be careful. you've got to put a bracket around t and put exactly what you're replacing with it. So this whole formula gets replaced with minus, essentially a minus 1 times. Then what goes into the t into the formula is 6 plus, oh, am I doing 4? Okay. 4 plus h squared plus 8 times 4 plus h. Okay, and it's important because if you put that minus in there, you're going to get a different answer. So what's 4 plus h squared? It's 16 plus 8h plus h squared, and all of it's going to get multiplied now by minus. So that's going to become minus 16 minus 8h and minus h. And I didn't do a very good job. There we go. Like that. All of it minus 8, minus 16. And did I do that right? Let's see. Minus positive 16. Looks like I did something wrong. It's just late at night. Oh, I know what I did wrong. Forgot to expand the other part of it. Foolish. So I get, what's 8 times 4? 32. What's 8 times h plus 8h? There you go. That makes some more sense. We can see right away that plus 32, minus 16 here, minus 16 there, and that's why the minus was important. Gets rid of all of the numbers, and we can see that plus 8h here matches minus 8h, and that wouldn't have happened if I hadn't done it properly. We can see one of the h's cancels out with one of the h's up here, so I'm left with minus h. Therefore, as h over 1, by the way, as h approaches 0, this becomes 0. We can prove the slope is flat. So that's a long way to do it, right? Let's do one more. We're going to do with time is equal to 6. So again, you just start with your formula, which says that s of t plus h minus s of t over h is going to give you the slope of your tangent. Well, in this case, we're using 6. What's 6 into the formula? You get minus 36 plus, and 8 times 6, 48. So you get plus minus 12. Minus positive 12. Okay? And what is 4 plus h into the formula? Okay, wherever I see 4 plus h, I must put my minus, then a bracket, then 4 plus h, and then square it, and then plus 8 times 4 plus h. And I must solve this stuff before I start subtracting here. This is essentially just minus 12, by the way. I just wanted to be clear of what the actual result was and what I was subtracting. So here, this again becomes the same. Oh, I'm using 6. Good thing I caught it. 6 and 8 times 6. I was doing 4 by mistake. 6. So this becomes 36, and when this minus applies to it, it's going to become minus 36. And then it's going to be plus 12h, but when this minus applies to it, it's going to become minus 12h. And then it's going to become plus h squared, but when the minus applies to it, it becomes minus h squared. Okay. And then this part of it, plus 8 times 6, plus 48, plus 8h, all of it minus 12. Now we can subtract it. Notice this minus 12 off this 48 makes 36, and then this 36 with this minus 36 cancels. So all the numbers cancel. Notice that this minus 12 here plus 8h is going to be equal to plus 4h. I think now I got something else wrong. 6 is 48, yeah, plus 8h. And that other one, is it plus 12h? 6 plus h becomes 36 plus 12h and then becomes negative. Okay, well, we'll just go with it. So we're left with negative 4h. There we go. That makes sense. So we're left with negative 4h. And then when I factor an h out of it, I'm left with negative 4 minus h. And remember, it's all being divided by h. So I'm left with finally negative 4 minus h, and when h becomes 0, negative 4. Which means my tangent right here, if I draw it in red, right here, for this spot here, is negative 4. Which makes sense because it's going down now. And it's not as steep as this one, which is plus 8. Because when you start to round the bend towards the vertex, the slope slows down a bit. Remember that as well. Geez, that was a long way to answer that question. I should not be taking that long. Sorry. My point is it's the same method over and over again. Okay, what about this one? This one, obviously, you're going to equation. They want the equation of the tangent line. So be careful. The tangent line equation is always a line. And then, so that means you're going to have to find out the tangent first. And then they tell you it's parallel to another line. Well, to figure out this line, get y all alone. So you get minus 6y to that side becomes x plus 4 is equal to positive 6y. Then when I divide, or if you want to multiply by the reciprocal on both sides, you must treat this as a bracket. You're left with 1, 6x plus 2 over 3 is equal to y. That's really important because the only part of this that I need is right there. That's the slope of that line. And all the lines that are parallel share the same slope, which means that I'm going to have a slope for this line that matches the tangent for this line. I just need to, okay, now I just need to make the tangent of this equal to that slope to figure out what value of x we're talking about. So first I have to find a general equation for that, and it's the same thing. I'm going to do f of x plus h minus f of x all over h as h approaches 0. You'd have a limit here as h approaches 0, like that. I just don't bother writing this part. So you cannot solve it because we don't have an x yet, but you can put in these brackets x plus h plus 1. So when we replace the actual formula, these terms with the actual formula, we get this square root of x plus h plus 1 minus the square root of x plus 1. And that's what this is equal to, and that's what this is equal to, because I put the x plus h where I saw x, all of it divided by h. And here's where your conjugate practice comes in. The only way to get rid of that is to multiply it by itself, top and bottom, and just remember to make the signs opposite. All of it divided like that. You do not have to multiply these out. Keep this in mind. Just leave the h hanging out multiplying this whole bracket. Okay? But up here, when this multiplies itself, we're left with x plus h plus 1. And when this multiplies itself, we're left with minus. And in brackets, you must put the whole thing in brackets. Okay? And all of it over the bottom, which I'm just going to leave alone. Okay? We're going to just resolve this. You get x plus h plus 1 minus x minus 1. So these cancel out. And these cancel out. So we're left with h on top all over h, which is that one there, times this, right? Times this. Well, these are treated as a bracket, and these cancel out. So finally we're left with 1 I'll just rewrite it. We're left with 1 over the square root, all of this, but now look what happens when h approaches 0. We're left with x plus 1 plus x plus 1, right? Which is the same as 1 over 2 times x plus 1. Because these are two apples being added together, so I have two apples. All right? All we have to do now to figure out which x value we're specifically talking about is we know it matches it's going to equal the same slope as that line. So now we've got to solve for x. Whenever you have an x as a numerator, by the way, this is 1 over 6. Whenever you have an x as down in the denominator and you want to get it to x equals to something, whenever you have an equation x equals to something, it's x over 1, or it's essentially saying x must be in the numerator. So how do you get this up top? And this is where a lot of students are weak. The solution to any time you want to get rid of a denominator, let's say you want to get rid of this denominator, is to multiply this thing by its reciprocal. In other words, put whatever you want to get rid of down there by 3, by the opposite over 1. Okay, that's good advice. I think we can just even leave the 2 down there. Let's just leave the 2 down there and see what happens. We're just going to multiply it by this reciprocal. Put it in brackets if you have trouble seeing it. You might say, don't I have to put the 2 up? You can put the 2 up if you want. You're just going to be bringing it back, though. Since the 2 is multiplying it, you don't have to keep them as a couple. Over 1, but the problem is if I multiply the left side of this equation by something that is clearly not 1, I must multiply the right side of the equation with it. You're going to discover on the left side every time, look, these cancel out. That's why we did it. What are we left with here? 1 over 1 times 2, which is 1 over 2. So we're left with 1 over 2 on this side. What are we left with on the right side? Well, let's not worry about it just yet. We're essentially left with this over 6 now. Oh, we've got an x to the top of a numerator. Look at that. It's x over 6. That's why I like to say multiply by the reciprocal, because this becomes clear. Now, how do I get rid of this being divided by 6? Same rule. I'm going to multiply it by the reciprocal on both sides. These are going to cancel out. That's why we did it. And you can see that 6 divided by 2 here becomes 3. So now we know that x, the square root of x plus 1, is going to be equal to 3. Well, how do we solve the square root? Well, we have to square it on both sides to get rid of that square root. If we're going to square it on this right side, we must square everything that was over here by 2 as well. Okay, this square gets rid of the square root. This square turns this 3 into 9. So we get 9 is equal to x plus 1. And that's what's the last thing we must do to both sides? X is equal to 8. So we discover that at x is equal to 8, and if they want, they want us to determine the equation of the line that is tangent. Great. Well, now we must figure out what the y value is. So when I put 8 in here, I get 8 plus 1, square root is 3. So we're talking about 8 comma 3. And now, since we have the slope, 1 over 6, and we have a point of line, we can now rewrite our line formula for our tangent line. And we're looking for b. We know a point here. It's 3. Yeah, it's 3. We know m is 1 over 6. We have an x plus b. So we're left with 3 is equal to 8 over 6, which is 4 over 3, plus b. We're going to subtract 4 over 3. And you might say, why am I not multiplying by the reciprocal? Get rid of it. Because this whole number here is being added to b. If you want to rearrange it, this is another way to look at it. Well, to get rid of this is the same as that. Don't start misunderstanding what's going on. To get rid of something that's being added to something, you must subtract it as a whole. And if I subtract it as a whole on one side, I must subtract it as a whole on the other. So this gets rid of it on this side. For us to figure this out, we should convert 3 to a fraction over 3, which is 9 over 3. How did I figure that out? You just multiply by 3 over 3. You get 9 up here, 3 down here. So you get 9 over 3 minus 4 over 3, which becomes 5 over 3. That's b. So therefore, we can rewrite our line of our tangent is y is equal to 1/6, that's our slope, x, plus 5 over 3, that's our b. Boom, that's the equation of our tangent line. To do it, we had to figure out the tangent, the slope of this is equal to the derivative of that, or the the instantaneous velocity of that, to figure out the x value, to then plug it in to figure out the y value, to then come up with the line. Woo! I don't know if I'm going to bother with this C1, or with this H1 rather. 12? I don't think so. Okay, let's see what they're asking. For each function, use the definition of the derivative to determine whether a, b, c, m are constants. Okay, well, that's a constant, because y is just equal to the same letter over and over again. The m is not a constant. When I take the derivative of this, I'm going to be left with m. And I can do it the long route if you want, but I can already tell that m is going to be the slope. And then for this one, we'd have to do it. Oh, where a, b, c, and m are constants. Okay. Yeah. For each function, use the definition of the derivative. I don't know what they mean by the definition of the derivative, but I think what they mean is, if I go back to the book, what page am I on, by the way? 73, 74? The definition of the derivative is this. The delta x, delta y, delta x as x approaches 0. So it's pretty much the same thing. It's the same. It is the same thing. Just you got to take it in terms of delta x and delta y. So here, to determine the derivative of this, I guess this is just going to be c minus c over y is always c, and c plus h, it's just always going to be h. As h approaches 0, it's always going to be 0. I don't think it's always going to be, the constant. I don't know how to prove that in derivative format. I do know how to prove this one though. Okay, so it's going to be m x plus h plus b minus mx minus b. Why is it mx minus b? Because it's minus the whole thing, and this minus will apply to both, all over h. And if I multiply this out, I get mx plus mh plus b minus mx minus b. Look what cancels out. That, and that, and these two. And it's all being divided by h. So I can see what's left, that m is the derivative of that. And you can prove it. I imagine I could do it with this as well, except that there's no place to plug in x plus h. So you just end up with c minus c over c minus c. I'm not sure how you would do that. C plus h over h. So you just end up with h over h, but that just becomes 1, and I happen to know that the derivative of constant is 0. Maybe that just becomes 0 somehow. Okay, well, for y is equal to x, it's the same thing that we just did. It's going to be x plus h minus x all over h, and you can see that it's h over h, which is 1, which makes sense because there's a 1 there. So this is just a line. Makes sense that the slope is just 1. And then for this, you're going to discover that we're going to come up with 2ax plus b as the derivative. And you just do it like this. Ax plus h squared plus bx plus h plus c, all minus this. I'll get rid of my other garbage here. And so this minus is going to apply here, and here, and here, because the minus is going to distribute through. Here I'm going to be ended up with x squared plus 2xh plus h squared, all multiplied by a. So I get ax squared plus 2ax plus ah squared plus bx. Was it bx? I wish I'd just kept the thing. Plus bh plus c And you're going to discover this cancels out with that. So might as well get rid of it here. The bx here cancels out with that. And the minus c cancels out with this c. So I'm left with 2axh plus h squared a plus bh. Great. All over h. And when I factor an h out, I'm left with 2ax, which makes sense, yeah, plus ha plus bh. And when I factor divided by h, boom, boom, those disappear, which is the goal, to get rid of the denominator 0. And as h approaches 0, this disappears. So I'm left with the derivative of 2ax plus b. Oh, wait. Yeah, I missed one. This h shouldn't be there. Plus b. And that will be the derivative of ax squared plus bx plus c. Notice the pattern. It still works. This 1 came down in front of b, and then it became x to the 0. So it just came 1b. And this 2 came down in front, and that became 1, which is 2ax. Okay, and we'll go on to the next one. Hopefully I'm not going too fast, but essentially you're just substituting x plus h in over and over again. Does this function ever have a negative slope? If so, where? Well, that's easy. So you should just know what that is. It is a cubic. It's going to start in quadrant 3, go up, and go up. Now, technically, a cubic could have a slope like this. And on these spots here, it's going to be negative, right? Because it's going up, 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 hits the peak, and then comes down. But when it's a pure cubic like this, it's the same as x times x times x, which means there's only one spot it crosses the axis, which is at origin. And the only thing that happens there is it gets quite flat. So you can see it's positive, 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 kind of 0, but never quite positive. And then here, it's going up again. So the answer is no. Give reasons for your answer. Well, I know what the shape is, but if I take the derivative of this, I'm going to discover it's 3x squared, and then you're going to discover that no matter what x value I pop into there, right, because it gets squared, this is always going to pop out as positive. So once you do the plus h minus f of x plus h minus f of x, you'll discover that all that's left over is 3x squared when h goes to 0. And because x is squared, the derivative, or the slope, must always be positive, because the x value, any x value you take, gets squared and turns positive. So you can prove it by finding the derivative. And then here's this last one. Okay, I'm going to go like that, and just take crop. A football's kicked up in the air, so it starts on the ground. Its height h above the ground in meters in seconds is given by a distance, so it's a height, and it's too bad they use h, because that just confuses us. And what is that? You might say, well, rearrange it. Minus 4.9 t squared plus 18t. That's a downward facing parabola, right? And it's going to have two spots. It's going to have a 0 spot, 0, 0 origin. It's going to go up in the air and come back down. And we must well learn a little bit about it first. So if I take t out, I'm left with minus 4.9t plus 18. So the question is, when does this equal 0? In other words, when does the football hit the ground? We can do it like that. Okay. So we've got that. If I bring it down to this side instead, I'm left with 4.9t is equal to 18, which means t is equal to 18 divided by 4.9, which is essentially 18 divided by 4.9. 18 divided by 4.9. And you're going to discover you get a long thing like that. But this is just going to help us understand what's going on. Which means this ball is going to hit the ground right here at 3.6734, and its height is going to be 0. And that just helps to understand that the peak of this will be between 0, 0 and 3.6, which is roughly 1.836. So the question is, determine the derivative of this formula at the specific time of 2. Well, the specific time of 2 is right here. It's after the vertex. And what is happening to the tangent after the vertex? It's going down. So what does h of 2 represent? It represents the slope, how fast the ball is descending in meters per second at 2 seconds. So it's just reached the peak, and so you can say it represents the slope of the tangent, but it also represents how fast that ball is falling at that point. Okay, how do we determine it? Same thing we always do. X plus h, and in this case, the h is going to be really annoying, so I actually encourage you to change the height to an s, so it's not as confusing. So it's going to be s of t plus h minus s of t. And they're using 2 seconds here, so it would help to figure out, we're going to need to know s of t. So when I put in 2 here, I get 36, minus, when I put in 2 here, I get 4 times 4.9. Okay, so what is 36 minus 4 times 4.9? 16.4. 16.4. Which means s of t is going to be 16.4 in terms of its distance above the ground. Well, what's t plus h? Okay, s of t plus h is going to be replaced with 18, not times t, but t plus h. And instead of t, I'm going to put in 2 plus h. Then it's going to be minus 4.9 times t squared. What is t squared? It's 2 plus h squared. Now we all just have to expand this to figure out what we're subtracting. So we get 36 plus 18h, and the expansion of this is 4 plus 4h plus h squared, all of it times negative 4.9 squared. Not squared, times negative 4.9. So you're going to get, oh geez, 16, and what's 4, 1836? I think it's 19.6. I'm just going to go with that. Minus 19.6. Minus 4.9h squared. So just to make sure, because I hate going back and forth on these. Divided by 10 because I screwed it up. Times 4. 19.6. Good. So you're going to get 36. And that's an h here. Minus 18h. Minus 19.6. Minus 19.6. Minus this. All minus this. And you're going to discover that this 19.6 plus minus this 0.4 becomes minus 20, minus 36, cancels that one out. If it doesn't, you made an arithmetic error somewhere. So you're going to get that. Oh, with that, gets rid of that one. Sorry, not that one. And that one. Okay? And then you discover that we've got minus 18h minus 19.6h, which is minus 37.6h. And we've got a minus 4.9h squared, which I think, let's see, oh, is that plus 18h minus, That's not minus 13, it's minus 1.6h minus 4.9h squared all over h. Okay. You're going to discover that when we cancel out these h's, you're going to be left with minus 1.6 minus whatever it was. It doesn't really, 4.9h. And as h approaches 0, this whole thing becomes 0. So we've got minus 1.6 meters per second. And that's how fast the velocity of this ball is falling at that particular point. The reason it's negative is because we've reached the peak of the vertex and we're coming down. Woof. Okay, with its corresponding derivative. That's interesting. And useful. Okay, so it's A. I'm going to put them in green blocks. Actually, I'm going to get them all alone. There we go. So we're doing this, and this are the main graphs. Oh, no, I got it wrong. Left are the main graphs. Good. What is this one? It's a downward facing parabola. And you're going to discover that whenever you take any x squared value, its derivative is going to be a line. It's going to be a line. So the only way a parabola can have a line is that one. So that means that if you don't believe me, just notice the vertex here and is at 0, 2, and just make a parabola of x squared plus 2, and it's negative. Take the derivative of it. Use x plus h and x and solve it for that, and you'll discover you're left with negative 2x. Well, what is negative 2x as an equation? It's a line. And I know I've said that this always equals the slope of a tangent, but if you're then going to use this as an equation and plug it into Desmos, Desmos is going to draw you a line. So this is a line representing various slope possibilities for different x's. It's not representing the line of the tangent at any particular point. It's representing a line, a graphic representation of the formula of the slope. Hope that makes sense. That's pretty confusing. But anyway, you'll discover that it can only derive to a line. If you look at this, right away, you can see that that looks a lot like x cubed, doesn't it? And once you take the derivative, what you're going to be left with is 3x squared. What is that? That's an upward-facing parabola. So you're going to discover the only one that matches that, because you'd be tempted to go with this one, wouldn't you? The only one that matches that is this. And if you want, just take the derivative of a cubic, 3x squared. Do this. It's going to be x cubed on one side, and it's going to be x plus h cubed on the other, and it's going to be subtracted. On this one, you're going to be left with h cubed. Oh, geez. Let me see if I can remember it. It's 1, 2, 2, 1. Or is it 1, 3, 3, 1? It's 1, 2, 1. It's 1, 3, 3, 1. So you're going to be left with 3x squared h plus 3x h squared plus h cubed minus x cubed. You're going to discover that this cancels out. So you're left with this. You're going to discover that this h cancels out, that one of these h cancels out, one of these h cancels out with the bottom. So the bottom's gone now. And when these approach 0, they disappear, and there's the derivative. 3x squared, it only matches a parabola, which of course only leaves this one left. But what is that shape? That shape looks like a sort of variation of x to the 4, but I can see it goes through two different points. So we're going to have 1x squared. We're going to have an x plus 3.5 is another, and an x minus 3.5 is another. But it doesn't matter. Just treat it as an x to the 4. And when you take the derivative of that, you're going to be left with something like x 4x cubed. You're going to be left with a cubic Well, there's a cubic. And the interesting lesson here is this. When you're dealing with a graph to the power of 5, its derivative is going to become one less of an exponent. When you're dealing with a graph that's a cubic, its derivative, once you take the instant rate of change, which is the same as derivative, will become a cubic. When you're dealing with a cubic, the derivative will become a parabola. When you're dealing with a parabola, the derivative will become a line. And when you're dealing with a line, the derivative will be a constant, as in one number, like 4. And that makes sense because when you look at a line, 4 is the slope of that graph at all times. It never changes. So that's why the derivative becomes a constant. But it's important to know, because then you can spot mistakes. Okay, part C, the tough part. I haven't spazzed out too much this time. And pardon me if spaz has become a derogatory term. I'm not up on my political correctness. Okay, for the function the x times the absolute value of x show that where x is 0 exists. What is the value? Well, that's a good point. If this was a normal curve, it'd just be x times x, which would be x squared, and we just have something that looks like this. Since we are dealing with all positive x values for a parabola, I believe that this shape will be the same as that, and that the slope of f of 0 will be a flat line. But let's prove it. As I said before, the right side of this is going to be x times x, because the right side of this is just whatever's in there. So it's going to be a parabola. And the left side is going to be x times minus x, right? And that just is a way of saying that for absolute values, whereas normally we'd take a minus 3 up here, we now turn it into positive. Oh, that's interesting. So that means, whereas it would normally just go up like that, I believe it's going to go down like that. And we're going to have a flat surface right there. And the reason it now enters negative is, take a look. If I was dealing with minus 3 here, this would be minus 3. But this minus would make my minus 3 plus 3, which brings me back into the negative side. So I'm going to have a thing that looks like it should be a parabola, but this side of the parabola is going to be mirrored downwards. And that's all that minus is going to be doing. And which means, since my right side is approaching 0 and my left side is approaching 0, it exists there. And you can take the derivative of this side, and it's going to become 2x. And you can take the derivative of this side, which is minus x squared, so it's going to become minus 2x. But you can see that when we plug in 0 for both of these, they both equal 0. Therefore, it exists. And just to confirm, we're going to put in Desmos, and it takes me an hour to load up Desmos. Yeah, it already is doing it. Slow. And you can always visually put in the graphic. So we're going to do x times the absolute value of x. Yeah, sure enough. And now I'm going to just put up y is equal to x squared so that you can see it and compare it. There you go. See how the red line is perfectly mirrored in the x-axis? That's because all those values that were supposed to go up here are now going down. And that's what the absolute value did. You can also do it representing it the way we did it. Times x times minus x. There. Except you see on the right side it's making it go down again. So it's just a way of saying that you can actually try to make x smaller than 0. There we go. There. I've done it. So I've just drawn it only on the left side. You can see how it matches the left side of that one. I don't know how useful that was. Anyway, proven as far as I'm concerned. Because the derivative of one side when x is equal to 0 is the same as the derivative of the other side. If f of a is equal to 0 and the derivative of it is 6, find the limit of this. Ooh, baby. So if when we plug in a, we get 0. So my first thing would be to say that, ooh, why is it divided by 2h? Wow, how do I prove that? And the derivative of it is x. Jesus. Wow, that just kind of blew my mind a bit, and I wasn't ready for it. Well, I know the derivative of this, so the value at a, so we have an a comma 0. So I know when a is there, the other point is 0, and I get that from that. And I know that the f of a is equal to 6. So that means we're dealing with a line, because I have a constant for a derivative at that point. Okay? Unless they're telling me, yeah, because they don't give me a, so I know I'm dealing with a line. Find the limit as h approaches 0 of this. Ugh, I don't know if I can. Wow. Yeah, mind blown. Consult your teacher. Give an example of a function that's continuous along this, but not differentiable at x is equal to 3. Okay. That would be f of x is equal to the absolute value of x minus 3. And that's because you're going to have such a sharp value here that that's not differentiable, but yet it's continuous. See, it goes on and on. At what point on this graph is the well, I'm not doing that. We did that one already. So find the slope of this. You're going to discover it's y is equal to 2x minus 1. There's the slope. And then at what point of the graph is the tangent parallel to this 2? Well, it's when 2x minus 4, and that's what you'll find when you take the derivative of that, is equal to 2, which is 2x is equal to 6, when x is equal to 3. And then you plug 3 in, you get 9 minus 12 minus 5, which is minus 17, so minus 8. So the point will be 3 comma minus 8. How did I do that? Okay, find the slope, do the normal derivative thing of it, discover what it is, get rid of all the h's, and you're going to be left with 2x minus 4 when you're done. Make that equal to the slope, which is 2. Solve for x. Once you find x, plug it back into the original equation to find your y, and there you'll have the point. Want me to do the steps again in case that was too fast? Okay, step 1. Step 1, find slope of the line. Step 2, find derivative general of that equation using the f of x plus h minus f of x, and it's going to take time, and you're going to be left with a derivative once h reaches 0. Step 3, make that derivative equal the slope you found, which was 2. Step 4, solve for x. Step 5, put the value of x into the original equation function to find the y value. Done. And finally this. Determine the equation of both lines that are tangent to the graph of f of x and pass through points through the point 1. Ah, well, that's interesting. Okay. So that what we're talking about here is a parabola. And this parabola is a standard parabola. It's going to go, let's use a red line. It's going to go down through origin, and up. And it's going to look better than that. And still not good. All right, good enough. And it's also going to pass through this point, 1 minus 3. So you'll notice that if I draw a line through this, up this way, I'm going to pass through the parabola here. But if I draw a line this way, I'm going to pass through the parabola at a higher point. But it's still possible. So the tangent of this is going to be equal. It's going to have a negative value, and it's going to pass through that slope. So I just have to find the tangent of that. And then I have to find the tangent of this. Once you find this tangent, you're going to discover that the tangent equation is 2x. Okay? Now, you can't use this point. However, you know 2x is going to be equal to the m of this line. Okay? You don't know the b. But you do know that the tangent point 2x over here, but it's a different x, so I can't use the same equation, is also going to go through that point. So you could call it x1 and x2. Well, let's see if there's a way of finding that out. Oh, there's this. So if you call this x1 and y1, you'll know that minus 3 minus y1 over 1 minus x1 is going to be equal to 2x1. Great. That might be a good start. Because what I'm doing is I'm finding delta y over delta x is equal to, what do I know? The equation of this tangent 2x, and I'm using specifically 2x1. Interesting. Maybe that will help. Let's see. Okay, let's just solve for x essentially. So we got 1 minus x is going to be equal to 2x. So we're left with minus 3 minus y is equal to 2x times 1 minus x. We're not going to be able to solve. And we're left with minus 3, and I might be going down the wrong path here, is equal to 2x minus 2x squared, okay, which means that y is going to be equal to 2x squared minus 2x minus 3. So all I did there was put the y on this side and these other ones on that side. So now we have an equation for y, for this particular y value, that's based on this particular x value. Yeah, not very useful. So I don't think that's the way to do it. What I think I can do is use that point, knowing that it's going to be the difference between this one and difference between this one, and that they're both going to fall on that graph. Well, that's interesting. Boy, this is tough. All I know is 2x is going to be the slope of this graph and the point of it. But I don't know the value of x. And will these slopes be perpendicular? That would help to know if these slopes are automatically perpendicular. They probably are. For this tangent to go through this point, it's probably perpendicular slope to that. Yuck. So I'd love to go into the book and figure this out. I think I'm just going to waste too much time. Well, you know what? You can just quit watching the video, and I'll just see if I can do it knowing. No, that's not going to be equal to that, except that I know it's going to be 2 times x. I know that 2x has something to do with it. And I know it's going to be equal to the slope between those 2 points. And that x is going to be in that point as well. But that's not enough to tell me the point B. Wow. My brain just doesn't work this late at night. Oh well, I give up. I'm probably going to cheat, look, and put it in the